Let us look at this logical question. Why does sulfur have more covalent bonds than oxygen, though they are in the same group? You know that both sulfur and oxygen are in the same group 6A of the periodic table. What that means is that both sulfur and oxygen atoms have the same valence electrons, meaning that the last shell of oxygen has 6 electrons. So also sulfur. Why it is like this is because 2 electrons are unpaired. I'm going to reveal this using orbital diagram. You know that primarily, now looking at this, you understand that both oxygen and sulfur exist like this. They can have 2 bonds around them. But in the case of sulfur, we can also have something like this. 4 bonds. We can also have something like this. 6 bonds. But oxygen cannot exist this way. And that is what the question is saying. Now let me answer it by drawing the orbital diagram of sulfur atom. But before I do that, I want to remind you why these two are possible. In the electronic structure of sulfur and also oxygen, there are empty 3d orbitals. But the difference between sulfur and oxygen atom is that the empty 3d orbitals of oxygen are more unstable. They are high in energy. So because of this higher energy, electrons cannot easily quantum jump into that orbital. But in sulfur, the empty 3d orbitals can accommodate electrons. They are lower in energy, meaning that there is possibility of excitation of electron into the empty d orbitals, which creates more unpaired electrons and consequently more covalent bonds. Let me now explain this using the orbital diagram. Stay tuned. These are the available orbitals that the 16 electrons of sulfur can occupy. S is not degenerate, P is degenerate, not D is degenerate, not S can occupy a pair of electrons, the same thing here. P is degenerate. S will pair immediately, right? These are 12 electrons, remaining 4. The 4 will now enter 3p orbitals singly before pairing. And the 4th one will pair up. You can now see that from here we have 2 unpaired electrons, and that is why sulfur can exist like this. So also oxygen. Now let me repeat these orbitals. This pair of electrons, one electron can quantum jump into the 3d orbital, which is lower in energy. So when that one leaves, it will get into the 3d orbital, thereby creating 4 unpaired electrons. And this is the kind of electronic structure of sulfur that leads to formation of sulfur compounds in which sulfur exists like this. Example is sulfur 4 oxide, trioxosulfate, 4 acid, and so on and so forth. I hope you are following. Now, if this video makes sense to you, quickly share it to others. Make sure you are following us on TikTok and subscribe to my YouTube channel. There is possibility of an electron in 3s orbital to also quantum jump into the empty 3d orbital. Let me represent that. So like I said, there is a possibility of this electron to quantum jump into the empty 3d orbital, creating how many unpaired electrons now? 1, 2, 3, 4, 5, 6. And in this case, the sulfur atom can form compounds in which the atom is in this form, sulfur 6. And you have had compounds like sulfur 6 oxide, tetraoxosulfate 6 acid, and so on and so forth. The ability of the sulfur atom to allow electrons from lower orbitals to quantum jump into the higher orbitals, like empty 3d orbitals, is the reason why sulfur has more covalent bonds than oxygen, because oxygen atoms are incapable of doing the same.